Hello. In this video I will show you how to use one fixed support and one simple support center load, shear moment, and deflection of beams calculator in Mechanical Engineer Partnership website. In the menu bar choose calculators and then choose shear moment and deflection of beams, and then choose one fixed support and one simple support center load unit. In the left side is data, metric and imperial units, and in blue color, we obtain the results in metric units respectively imperial units. Data are following dimensions: the length L, of the beam, in meters or inch, force F, in Newton or pound force, and in absolute, the results are positive or negative related to the sign convention X, distance in meters or inches. In this calculation we have, XY plan as in figure, and Z-axis perpendicular on XY plan. Module of elasticity E in gigapascal or psi, about the second moment of area in this case is, in centimeter to the fourth power or inch to the fourth power. Figure shows a beam fixed in a support, by reaction R1 and moment M1 and simply supported on C support by reaction R2, and loaded by 1 F force located in the middle of the beam, in point B. How the shear force and the bending moment are calculated. All studies, materials, and formulas used in these calculation sheets are in reference with Mechanical Engineering Design, Book 7th edition, by Joseph E. Shigley 2004. The following rules are utilized: if the beam is cut at some section located at X and the left-hand portion is removed as a free body, an internal shear force V and bending moment M must act on the cut surface to ensure equilibrium. The shear force is obtained by summing the forces on the isolated section. The bending moment is the sum of the moments of the forces to the left of the section taken about an axis through the isolated section. The sign conventions used for bending moment and shear forces are, clockwise for positive moments and counterclockwise for negative moments. Positive shear forces in the same direction as y-axis in the figure and negative shear forces for opposite orientation. Analyzing the graphic we observe, the shear force is positive, between points A and B, and negative between points B and C. The maximum absolute value of shear force is between A and B point. Bending moment is a linear function of x coordinate, negative or positive, and maximum in absolute value in a point, B is an inflection point of bending moment, smaller than bending moment in a point. The moment has zero values in C point, and in x-coordinate value between A and B points. The results are, force reaction of the A support R1, moment reaction of the A support M1. Force reaction of the C support R2, moment reaction of the C support M2, shear force in beam at x distance Vx, bending moment in beam at x distance Mx, deflection of beam at x distance X, maximum bending moment in beam Max, maximum shear force in beam V. Max deflection of beam Max is function of distance x. Use the value of deflection of beam at x distance x to find y max. Maximum bending moment in beam Max and maximum shear force in beam V are used in calculation of normal and shear stresses. See the pages with stress calculators. Initial data in International System Unit in left side have equivalent data in Imperial System Unit in the right, but the two blocks work independently. Let's have an example in imperial units: 200 inches for the length of the beam, 300 pound forces for F force, and then, 100 inches for X distance, module of elasticity 30 megapound forces per square inch. In regard to second moment of area, if you have already the value, write it in correspondent cellule, in inch to the fourth power. If not, choose calculators and then area moment of inertia, choose your beam section, for example, an hollow rectangular section, choose the dimension of rectangular beam, interior width by 4 inches, interior height 5 inches, exterior width be 4.5 inches, exterior height 5.5 inches, calculate, choose area moment of inertia about x-axis 9, in this specific case, copy the value and return to one fixed support and one simple support intermediate load, shear moment, and deflection of beam, calculator, paste the value of area moment of inertia, in second moment of area is cellule, replace the length L, 200 inches, 300 pound forces for F force, and then, 100 inches for X distance, module of elasticity 30 megapound forces per square inch, and then, calculate. The results are in the blue table. As I related in the precedent paragraph, max deflection of beam Emax is function of distance, and you can obtain the value by testing for several values of X coordinates. Maximus value of shear, bending moment, and deflection are generally used for dimensioning a beam. Similar calculation in metric units, data, and results. At the bottom you can use the buttons to update, refresh, print or submit. You can print or save PDF file your calculation. For quality of your work, use these calculator sheets for verification complementary with other calculators, or methods like finite element, and to find these geometrical properties. Thank you. And see the other videos with explanations about beam's deflection, area moment of inertia, and the calculation of stress.